Okay, recording started. Welcome to the Manhattan GMAT Study Hall, March 29th edition. So today's topic is flexibility in methods of problem solving. And what that means is we're going to take a look at some problems, most of which are, so to speak, favorites from the forum. Problems that people, maybe you can call them least favorites, but problems about which people tend to have more than the usual amount of questions, but that can be solved in many different ways. And the focus of today's class is going to be on all of the different ways in which you can solve these kinds of problems. Lots of different approaches, that's the focus. So let's take a look at the preliminaries. If you're an old hand here, you'll know how this works. If not, we have to show you the forum rules. We have to show you examples, things like that, then we'll get going. So here's the forum rules. The first thing, the problems that you should submit, please don't submit things that are too general. Please don't submit things that are too specific, and don't submit personal issues. So the last couple of weeks, people have been doing more than the usual amount of this. So just sending in specific problems, like here's a problem and I don't know why it's C and not B kind of thing. If you have that, then please post those on the forum. That's actually why we made a forum, so that people could take these really specific point questions and post them on the forum. So please use the forum for that. Thank you. Also, problems that are too general. In the last couple of weeks, we've had people ask questions like, I need to know how to get better at the GMAT so that my score can go from this to that. I mean, you're basically asking about the whole test all at once. That's also not really something that can be done. I mean, there's a reason why we have so much material and so many classes, etc., because it's a very complicated exam. So you can't ask about the whole exam at once. Finally, personal issues. Remember, this is a recording that's ultimately going to be watched by hundreds, perhaps even thousands of people. So please don't post your own personal issues and scores and things like that. This is not the place. So this is not the place for I have such and such a score and I want to get to such and such a score and what should I do? I mean, there's a folder on the forum for that. It's called the General Questions folder. That's what you should use that for, is general questions about study plans and so forth. If it's a question about admissions, there's an Ask an Admissions Consultant folder, which is moderated by our partner firm, MBA Mission. So you can also post questions about admissions in that folder. What you should submit is problems of intermediate depth. For example, one of the problems from a while ago was the median. The median is not too specific. It's not a single problem, but it's also not something so generic that we can't use it. It's right in the middle, which is what makes it a good topic. And then don't forget, you got to cite sources. Ladies and gentlemen, please cite the source of the problem. Where did you get it? And this means original source. This does not mean another forum. This does not mean a compilation that you found on the internet. This means the actual original authorship of the problem. So we need you guys to cite the sources. We need you to tell us where you got the problems from. And that cannot be the official guide. So if you understand these rules, let me see the smiley face icon again, please. Click that if you understand these rules. Forum rules. Okay, good stuff. All right. Remember, please don't submit official guide problems. Don't take the time. We can't use them. Please don't submit single questions. Also, please don't be rude or demanding. What you've got to get a hold of in this day and age of written communication is what kinds of communication are okay in this sort of professional situation and what kinds are not. So this probably differs from language to language, and that's why people sometimes have a hard time with it. But remember that if you're going to be doing business in English, you definitely have to understand what is rude in English and what is not rude in English. And things like, I expect you to reply, or I submitted this 3 weeks ago, where's the study hall on it? Or things like that. Those would probably have some degree of rudeness in any language, but in professional English, this is not acceptable conduct, so please don't do it. There you go. So, all right, remember to check the archives also. There's about 55 sessions archived now. It's a lot. We've been doing this for about 2.5 years at this point. So what this means is that a generic topic is very likely to have been covered already. What that means is if you want to submit a topic, make sure that it hasn't been covered yet. If it has been covered, then watch the study hall where we covered it. And then if there's still some angle or aspect on the problem that we haven't really treated yet, then please tell us more specifically what is that aspect. Like what part of that problem have we not touched? So please let us know. Thank you. All right, those are the forum rules. If you understand all of that, give me a smiley face and we'll start jumping into some problems here. If you are a latecomer, please remember please know that today's study hall topic is flexibility in problem-solving methods. What this means is that this, ladies and gentlemen, is the point of today's lecture. The point is to solve the problems in as many different ways as possible. So we're not looking for a single solution to these. That's not the point of today. The point is to come at today's problems from different angles. So with that said, sorry, I meant to show you this. Flexibility in problem-solving methods. This is today's theme. The point is to solve these things in as many different ways as possible. So I don't think you saw that screen for a second. Okay, so let's do it. When you solve these problems, remember that there's going to be answer buttons. Those should appear on your screen momentarily. Here they are right now. You should see those. They should have just appeared. Underneath the list of names over there, A, B, C, D, E buttons. Please use these to answer the questions that show up on the board. Please do not answer the questions in the text box. Also, please click just one time. If you click twice, then the second click will undo the first click. And we don't want that. That'd be bad. All right, let's do it. Here's our first problem today. Remember, please use the answer buttons when you solve this problem. We're going to go ahead and put a clock on the board here in a second. But remember to please use the answer buttons to solve the problem. Here's a clock. All of these problems are from the GMAT Prep software. Every problem today is from there. Okay, ladies and gentlemen, there's still quite a few of you who don't have an answer choice selected. So if that's you, then please select an answer choice. Remember that the answer buttons are over there on your left. Also remember that this is the GMAT, and the GMAT is not a test on which you are allowed to leave things blank. So if you that's why we're asking you to please select an answer on every question. And when you practice at home, you should do the same thing. You should select an actual answer choice to every question, even if it's a guess. So, okay, answers are visible. Let's fix that. You should not be able to see the answers anymore. Okay, sorry about that. That's just an option that I forgot to turn off. Okay, Yeah, I think that may have affected the answers here because a couple people who didn't have D changed their answer to D. So my fault for letting the answers be visible. But here are the answers from the class. Again, these may not mean a whole lot right now because there were 2 or 3 people who had E and then switched it, presumably after seeing other people's answers. But okay, from now on you won't see the answers from the other participants. That was just a mistake on my part. Okay, so let's take a look. What's one way that you can solve this problem? Well, one way, of course, is going to be algebra. So we'll go ahead and look at an algebraic solution first. But then remember that today's theme is flexibility, so it's not going to just be an algebra solution. We're going to look at that first, but we're also going to look at other stuff. Let's take a look at the algebraic solution. And the first thing to remember is that in word problems, in general, this is a theme we've touched on before in previous study halls. It's also something that you learn in the materials in the course and so on. But when you see a word problem, regardless of what kind of solution you're going to use, the first thing you should do is read it twice. So as a quick reminder of that, if you see a word problem, you should read it 2 times. The first time you should read it, you should ignore all math. You should just get the situation of the problem. Just understand what is going on in the problem. In particular, what are the quantities in the problem? And like under what circumstances or how do they interact with each other? Under what circumstances, how do they interact? Then the second time you read the problem, then you're looking at math. But one thing you want to make sure that you don't do is try to do math while you're reading the problem. Because that's just going to result in confusion. So let's read it the first time. So there were a bunch of workers who agreed to share the cost of a lunch. But then some of them failed to honor that obligation. And so then the other people got stuck with the bill. So what we can do just from that is make a chart. You should make a chart before you have any math. So what kind of chart could we make in this problem? Does anybody have any ideas that could go in the text box? What kind of chart could you make here? No, you guys are awfully quiet here. Chart? No chart? I'm not sure how you would make a Venn diagram, but maybe you could elaborate on that. Someone named Color the Board says RTD. It's not literally RTD, but that's the right idea. The same kind of thing. So it's not going to be cost minus paid equals leftover. So let me address these 2 things that people wrote. Someone wrote this isn't really going to work because nothing is left over. Like there's no unpaid cost. If you had people who didn't pay and their bills were just left outstanding, you could do something like that. But there are no outstanding bills here because the other people take care of the charges for the people who think on it. So unless you meant something else by that. And then this, I'm not sure how this would work. If you are the one who posted it, then maybe you could explain. But okay, what I'm thinking is more like it's like the rate time distance type of situation that another poster was talking about. So let's take a look at that. So you can make a chart here that's sort of like rate time distance. Except instead of rate times time equals distance, it's amount per person times number of people equals total money. And then these are the quantities. Notice that you don't really need to have, and you don't need any actual math to make this kind of chart. And then the rows in the chart would correspond to what in this case? If the columns are amount per person and people and money, then what would the rows of the chart correspond to? Anyone? Yeah, so color the board's got the right idea here. We're not talking about what goes in the chart because, I mean, of course you have numbers or values in the chart. That has to happen no matter what the chart is. That's not what we mean. What we mean is what color the board has said, which is the headings of those rows. So, yeah, you have an actual situation and you have the situation that was supposed to happen. So what should have happened versus what actually happened. So if you have this kind of framework before you get going on the problem, it will make the problem a lot easier to deal with than if you try to use no framework. So any questions so far, go ahead and type them in the text box. So the T coworkers in the office, that's T. Now we go back and do the math. Once you have the chart, go back and do the math. Okay, also, I think Mohan, this is you, but anybody, if your messages are set to just go to the moderator, please set them to go to everybody in the room so that when you post a chat box message, everyone can see it. Because otherwise I'll have to reproduce them all on the board, and that would be not great. All right, once you have the chart, go back and do the math. So there's T coworkers in an office if we're doing algebra. So it should have been T people. And the lunch cost a total of X dollars. And then S of the coworkers fail to pay. That means that S of them think out on their obligation. So what that means is that you have T take away S in this box. The cost of the lunch isn't going to change. The lunch is still X. And so now what you want is additional amount that each would have to contribute. So you can find these additional amounts by dividing. Because you've got this times this equals this, which means that if you need to find this column, then you can divide these two. So that's going to be X divided by T. And that's going to be X divided by T minus S. And then the additional amount that each would have to contribute, this is a bigger number. Because there's fewer people who wound up getting stuck with a bigger bill. So they're going to be paying more money each. So you have to subtract in that direction. It's the big fraction minus the small fraction. So X over T minus S minus X over t. So if you simplify this, if you make a common denominator, I'm going to presuppose that people in here know how to do this, so we'll skip these steps. If you make the common denominator and you simplify, you will get answer choice D. All right, so if you're going to do an algebra solution, this is valid, of course. The algebra solution obviously is something that works. But one of the most important lesson you can get out of this is to remember to read word problems twice. First, ignore the math and get the situation. Then go back and do the math. Any questions about this problem, this algebraic solution, go ahead and throw them in the chat box. Okay, does anybody know another way that you could do this problem? Remember, this is the main theme of today, is to be flexible with methods here. Yeah, let's plug numbers. So what's the giveaway? Like, what tells you that you can do that? Yeah, there's variables, although it's not just the fact that there are variables. Let's go ahead and look at some more examples of this, then we'll come back to this problem. So when can I? Oh, that's strange. When can I plug in my own numbers? So like in the book, they refer to it as the Vick method, but that's because it's being introduced to people who are pretty much total beginners. And so we try to simplify it to something that's really easy to recognize. But it's not just that. Like for instance, here are 3 problems that we might see. I'm not going to show them with answer choices, but there's that, and there's that, and then there's the one on the previous page. So you'll see some problems show up in a second. Okay. And then there's the problem on the previous page. So let me go ahead and get a quick photograph of the problem from the previous page. Okay, so here are 3 problems. Are there any of these problems where you cannot plug in? And I mean, the first one, I didn't put the choices up there, but the answer choices have. They're full of S's and T's. Anybody else? Are there any problems that you cannot plug in here? So yeah, it's number 1, and notice that number 1 does have variables in the choices. So it's not just a variables thing. I mean, if you look at it like that, you're going to overlook a lot of problems where this is a very good method. So it's not just variables in answer choices. Because this has variables, but you can't plug in. Can anybody summarize why not? Yeah, it's because they have a fixed value, right? So that's the real issue. The real issue is if you can't find the values, like if there are actually correct values, then you cannot plug in. Because when you plug in, what you're doing is you're basically making up a random value for a variable. And so if there are correct values, then it doesn't work. But if there's anything undetermined, like if there's any values that don't exist or that can have whatever values that you want them to have, then you can. So if any unknowns are not determined, then you can plug in. So in this problem, even though there are S's and T's all over the place, they're not variables, because S is a hard number. It's a very large number, which is why they gave it a letter name, because it's so big. But it's a hard number. It's the product of the integers from 100 to 200. And then so is T. So that's what's going on there. There's no unknowns. Like, these have correct values. On the other hand, in this problem, there's no variables in the choices. But in this problem, n can be any prime number greater than 3. So you can just plug in any prime number greater than 3. And then here, again, in the problem here, S and T can be any values that make sense. You can't solve for them. So just remember, thinking of it as variables in choices is only a starting point. That's not really what it is. That's just a rough approximation. What it really is if you have undetermined quantities, then you can do this. So let's look. Let's plug in your own numbers here. Because the reason why that works is because the numbers are not actually determined in the problem. In other words, there's no correct answer. So let's just pick a value for this. Let's move that down a little bit. Let's just say that the lunch costs a total of $60. Because 60 is a nice number. Like 60, every number between 1 and 6 goes into 60. So let's say x is 60. Make sure you write down the values. So x is 60. And let's say that t is 5, and then s is 2. So what should have happened is that 5 people should have paid, which would be $12. But actually, 5 minus 3 is 2 people. 5 minus 2 is 3 people paid. So they actually paid $20. So the answer is $8 additional. If we plug into the choices, x over t is 60 over 5. This is not correct. This is 60 over 2. That's 60 over 3. That's not correct. This is 2 times 60 over 3. That doesn't work. This is 2 times 60 over 5 times 3. That's 8. That's the answer we want. Remember, you have to keep going and make sure that nothing else works. So this would be 60 times 3 over 5, which is a very large number. That's not 8. So you can also plug in your own. Any questions? If you have questions about this, please type in the text box. I see one person typing, so we'll see what they are typing. Okay. Well, let's see. One person is typing, but we will go on, and if a question shows up, we'll address it. Let's talk about this. So on this last problem, we saw two ways. We saw two ways to solve the last problem. We solved it by algebra, and we solved it by plugging numbers. When you go back and study, which of the following is or are important? So tell me what you think. The first is figuring out which method is faster or fastest. The second is figuring out which method is easier or easiest. And the third is just learning as many methods as possible with no preference. Which ones of those do you think are important to do when you go back and study the problem? A, B, C, or whatever combination of those. You can type in the text box if you want. So what you should be telling me is just C and not the others. Let's talk about why. But the only one of these that's relevant here is learning as many methods as possible with no preference. Because the one thing you've got to remember, in fact, the defining characteristic of this test is that on the GMAT, the problems don't look like each other. Your test problems are not going to look like your practice problems. So, I mean, they'll test the same general underlying concepts, but this is not like school where you do a homework problem and then it looks exactly the same as the problem that you get on the test. Because if that's the situation, then yes, if something is the fastest way, then it'll still be the fastest way. But the consequence of this fact about the GMAT is that fastest and easiest are not meaningful concepts anymore. Like whatever is the fastest method on one problem could be very slow or even impossible on a similar problem. Also, the easiest method on one problem could be very hard or even impossible on a similar problem, because the problems will not resemble each other. So also to the person who wrote that easy and fast are the same thing, absolutely false. In fact, most fast ways of solving problems are fast because they are a little bit more elegant and more sort of advanced. Whereas the easy ways to do problems are very often things that take much longer. Like, for example, if you're doing a counting problem, a combinatorics problem, the easiest way is just to count everything, but that takes forever. And, you know, the more combinatorial ways to do it are harder, and that's why they're shorter. So that's not really a true statement. But this is huge, because like this should be the entire point of your quant studying. You should never really think about ranking the methods or trying to make a preference. Like this is the whole point of studying quant, is to learn lots and lots of ways to solve stuff. This is the thing. So there you go. Any questions? Quickly revisiting the problem that we did, one person in the chat box wrote the following, so let's address it. One person wrote, in a time frame of 2 minutes, what's the right choice of numbers? Does anybody have any idea how I'm going to answer that? It's not the wrong type of question. It's more just like shoot first, ask questions later, right? Just pick the first reasonable set of numbers that comes to mind. It's a time pressure test. So you can't dwell excessively on what numbers to pick. Once you find numbers that make sense, you should use them. I mean, it helps to have some kinds of things in your little mental repository. Like, for instance, this fact that 60 has divisors of 1 through 6 helped me here. Because I know that I need to figure out for different numbers of people, so 60 is a good number for that. But you shouldn't, excessively debate with yourself on it. So, if GMAT wasn't time sensitive, then we would all get 800. Probably not. I understand you're probably exaggerating there, but adding a ton of time wouldn't change a ton about the test. Like, a lot of the problems are insight based. And so you would do better if you had unlimited time, but at the same time, especially on data sufficiency, you wouldn't do that much better. Because if you are making a procedural error, or if you're having trouble with the format or something like that, then extra time's not going to help that. So, okay. One other person wrote this. Okay. One other question from the text box before we move on. Could I explain what I mean by the test will not look like the practice problems? Janet, if you want a more exact idea of this, what you should probably do is just look through the problems in the official guide, or supplement, or GMAT prep. And I mean, you'll see problems that test similar material. Like, you'll see problems about primes, and then you'll see other problems about primes. But no two problems will be formatted in the same way and be solved with exactly the same procedure. So, meaning it's not memorizable. You can't just memorize a bunch of rote procedures and grind them. Like, there's going to be variations in, it's kind of like in boxing. There's only a few punches that you can throw, but people can still come at you with endless combinations of those punches. So, same thing with the GMAT. All right, let's take a look at another problem. And yeah, let's do it. How about something like this? Go for it. Use the answer buttons again, please. The answers won't be visible this time, so don't be gun shy about clicking on the answers. Please use the answer buttons. Here's a timer. Okay, that is the end of the allotted time. So again, this is the GMAT. This is a test on which you must answer the questions. So please pick something even if you have to guess. Okay, so here on the board in a second, you're going to see the answer choices from the class. So here are those. So we've got mostly a split between A and C here, but you know, some decent variety of answers chosen. So let's take a look. This time, let's change it up and look at the what you would probably call the alternative method first. Like, what's a way of solving this problem without any sort of traditional probabilistic analysis? Yeah, you can just write them all out. Well, eliminate answer choices, what does that mean, right? You have to, if you're going to say eliminate answer choices, you have to say how you're going to do that. So, because eliminate answer choices could mean lots and lots and lots of different things. But yeah, you can just list all the possibilities. So, on lots and lots and lots of problems in probability and combinatorics, many, if not most, problems allow you to just list everything and solve it that way. So as long as if it's a combinatorics problem, there's theoretically always that possibility, unless there are just too many ways to do something. But on probability, there's also always that option, unless they're not equally likely events. So let's take a look at this. How are we going to list this? Well, we could just call the apples 1, 2, 3, 4, and 5. And then let's say that number 1 is the spoiled one. So we can just all of the ways of making 2 apples. Well, 1 and 2, 1 and 3, 1 and 4, 1 and 5. 2 and 3, 2 and 4, 2 and 5. 3 and 4, 3 and 5, 4 and 5. That's a really short list, right? That was very quick. So definitely something you should just try to do. You shouldn't spend a zillion years wondering whether this will work. You should just start trying it. Because, you know, if you start trying it and it gets out of hand, you can always just stop. You know, you're not committed. So you just got to start doing it. So which ones involve the spoiled apple? Well, these 4 do. So that's 4 out of 10. So your probability is 4 out of 10, which is 2 out of 5. Any questions about this? So there were a lot of people who had answer C to this, and there were a few people who had other answers. If you thought you were sure about that, then that's one thing. But if there was any degree of uncertainty about that, what you need to be asking yourself at this point is, why didn't I just go ahead and list everything? Because that's something that will work if you do it. So make sure it's a possibility that's on the table. Any questions, go ahead and throw them on the board. Okay. So, well, you can make the order matter if you want to. You can make the question work in a way such that order does matter. I mean, you'll just get twice as many possibilities. So I'll show you that real quick. So here's the only time you have to be really concerned with the issue of does order matter is if you're looking at a problem about combinatorics and they ask you how many ways. Because if the answer is how many ways, then if the order does matter, there are more ways. But if it's probability, that's a ratio, so it shouldn't make any difference, really. So you can phrase the problem, you can consider the problem in a way such that order matters, if you really want to. There's no reason why not. So if you do that, then you'll just have twice as many possibilities. 1 and 2, 1 and 3, 1 and 4, 1 and 5, 2 and 1, 2 and 3, 2 and 4, 2 and 5, 3 and 1, 3 and 2, 3 and 4, 3 and 5, 4 and 1, 4 and 2, 4 and 3, 4 and 5, and then 5 and 1, 5 and 2, 5 and 3, 5 and 4. I mean, that works. It's a little bit more clumsy, but if you want to think of it as a distinct first and second apple, you can do that. So these are all spoiled apple, and so are these. So it looks like we've got 8 out of 20 this time, which is still 2 out of 5. You can't do this with combinatorial problems because the answer to how many is different. But with probability, it doesn't usually make much of a difference, as long as you're consistent once you pick a way. All right. I don't see any other questions about it, so let's move on. Let's look at you can look at a couple more traditional ways to solve this thing, like traditional probabilistic analysis. Well, if you consider this as an order matters problem, then you can multiply consecutive probabilities. You can do probability that the first is spoiled, which would be 1 out of 5. That you don't have to multiply that by anything. But if you want the second one to be spoiled, that means the first is unspoiled and the second is spoiled. So the first unspoiled, there's a probability of 4 out of 5, because anything but the spoiled one. And then out of the remaining 4, the second needs to be the one that's spoiled. So that's a fifth plus a fifth. You can do that. Or you could consider the opposite event. Yeah, what someone just wrote in the window. So you could do 1 minus the probability that both are unspoiled. So that's 1 minus unspoiled first time and unspoiled second time. So 4 out of 5 are unspoiled, and then there's still 3 out of 4 that are unspoiled. So that's 1 minus 3/5. You could also, if you know combinatorial stuff, which we won't go into that here, then you can also do that. You can also do like number of combinations that include the spoiled one divided by the total number of combinations. Again, we don't want to sidetrack this into a discussion about combinatorics, so we're not going to go into the details. But if you do that, it'll reduce to 2 out of 5. So there's so many different ways to solve this problem. And I mean, if you think too much about like easiest, fastest, stuff like that, you're basically cheating yourself out of learning the rest of these ways, which are very cool ways to solve the problem. So you don't want to cheat yourself out of solution methods. Any questions? Go ahead and ask, otherwise we will jump to another problem. Okay, try this one. Again, please, ladies and gentlemen, please use the answer buttons. The answer buttons look like that. All right, give it a shot. Here's your clock. Okay, we're sort of all over the place on this one. There's a lot of different answers being picked, but please choose an answer choice. Remember, it's the GMAT. I know you've heard me say this 100 zillion billion times by this point, but the GMAT is an exam on which you are not allowed to abstain from answering. So make sure that you pick something, please, in the next, 10 seconds or so. Okay, so if you are, I don't know how to pronounce Z-I-Y-I, if that's you, or if you are just Z-Y, or however you say that, but you got to answer the problem. You're the only person who's here right now who's not answering it, so remember that if you don't answer the questions, you're not preparing yourself for the test that you're going to go take. So we're sort of all over the place here, but let's take a look at, again, what one might call non-traditional methods first. How can you solve this without doing any algebra? Any ideas in the text box? Yeah, somebody wrote pick a few numbers. You don't need to pick a few numbers. I mean, make sure if you said this, maybe you didn't literally mean it, but if you did literally mean it, then it's not right. But maybe you were thinking of another method. So I want to address this real quick. This is the right idea, but you don't need to pick multiple numbers here. So on problem solving, on multiple choice, you only need to pick one value for each unknown quantity. So the only time you need another value, like you won't need another value unless you get two or more correct answers, meaning one or more wrong answers gives the right number by pure coincidence. I mean, that can happen. It's a rare event, but I mean, it's kind of it's kind of a black swan sort of event, but it can happen. So make sure you know that that's a possibility. The reason I'm addressing this is that there's another type of question where it's essential to pick more than one value, and what kind of question is that? Like, when do you have to pick more than one number if you're doing number testing? Yeah, it's data sufficiency, right. On data sufficiency, number testing always requires more than one choice for each unknown. Because remember that the issue in data sufficiency is not what's the number. It's, is there only one solution, or is there more than one? And I mean, that's a question that you can't answer without multiple plugins. So if you only plug in one time, you can't answer that question. So this is why I felt like I had to address this, because this is one distinction that you want to make sure that you have in mind. And I mean, here you know that you will not have to pick another number because these are mutually exclusive. Like, it's impossible for your answer to be in more than one of these ranges at the same time. Versus, like, if this said less than -10 and this said like between -100 and -5, those overlap, so you might not know the first time you plug in a number. But yeah. So let's plug in a number. I mean, you might need to think a little bit before you can find a number like this, but let's find a number that does this. So the square of n is less than 1 over 100. A square is something that's not negative. So we need to square, and it's not 0 because the number itself is not 0. So we need this, or if you like decimals, this. So let's try that. I mean, if you know squares, I mean, you might know, for instance, that, I mean, you can do what Rejoule is doing, although the fact that that's 100 and this is also 100 might confuse some people. So for now, I want to kind of stay away from that. I think most of you guys know that, say, 12 squared is 144. You'll see an exponent here in a second. So therefore you can use that if you can use square is 1 over 144. And so your number, as a result, is going to be plus or minus 112. But you want the one that's negative, because it tells you that. It says here that it's got to be a negative number. So you can use n is negative 112. And then if you can't think of this, if you don't think in this sort of way right away, then just, if you don't think like this kind of off the bat, then what you should do is just play around with numbers until you discover which ones have squares in this range. So then the reciprocal of n, which is the answer to the question, is negative 12. So that would be A. Negative 12 is less than negative 10. So here it's not necessarily super easy to pick a number, but you may find this to be a nice alternative if you get stuck on more traditional solutions to this thing. Any questions about this method, you can go ahead and throw them in the text box. Not. Here's another approach. I mean, this is the more kind of traditional approach to this problem. If you're going to use algebra, so we know that n squared is less than 1 over 100. Exponent is there. And then we also know that it's greater than 0 because it tells you that the number itself is not 0. So if you square root that, you got to be careful because the square root of n squared is not just n. The square root of n squared is absolute value of n. So this is a topic that our strategy guides deal with if you're not familiar with that. But you wind up with this. You wind up with an absolute value of n. But then because we know that n is negative, so the absolute value is the opposite of n. So that means this can be replaced with negative n in that inequality. You can divide this whole thing by -1, and that gives this. That's your inequality for n. And then if you take a reciprocal, that flips the inequality again. Because the inequality, reciprocals also work the opposite way. If you take the reciprocal of a smaller number, you get a bigger number. So you can't do the 0, so you just take this part of the inequality and do the reciprocal of it. So the reciprocal of n is 1 over n, and that's -10, and this flips again. So you can do that, but there's a lot of issues with the algebra here. So again, the main point of the problem is just that it's good to have other ways and also to have this. You should study this. You should also study algebra. You should not concern yourself with stuff like best or fastest or whatever. Here's a question that someone in the text box is asking. What do you guys think about that? And it depends if you're talking about when you do the problems, like i.e. when you take a test versus when you study or review them. These are different situations. Let's see if anybody knows where I'm going to go with this. If anybody has any thoughts about that, text box. Nobody. Nobody has any thoughts about this at all. Tough crowd. It shouldn't be a tough question. If you guys have the right kind of, it's what Jay is saying. It's exactly the point. So it's not the format of the answer. It's not I should memorize a rule. It's you should do whatever you feel comfortable with during the test. So, if you like decimals better, then do decimals. If you like fractions better, then do fractions. Everything we did here, you could also do with decimals. If I wanted to make that 0.01, that works. That's still 0.1, that's 0.1, that's -0.1. And then this is -10. Nothing is different. So if you personally are more comfortable with the pink decimals, then you should use those. And if you personally are more comfortable with the fractions, then you should use those. But you definitely should not try to memorize a whole bunch of rules about this, because all that's going to do is work against you. Because all that's going to do is make you hesitate even more when you solve the problem. Like, you're just going to sit there and wonder and wonder and wonder and think that there are all these issues that you have to think about. And there's not. The good thing here is that there's not really an issue here to think about. This is really just, if something comes to mind, do it. And if two things come to mind, and the way you feel about the first one is kind of but the way you feel about the second one is better, then do the second one. But you really don't want to, you really don't want to overcomplicate these issues. And I mean, that can't be emphasized enough. Like, you don't want a whole bunch of, like, nitpicky rules of procedure here, because they won't work. Like, if you get too specific with this, then it's only going to work for the one single problem that you're looking at, and it won't work anymore on other problems. Like, but if you have a very general sense, like, oh, hey, if I'm comfortable with something, then I should just do it, then that's so much better. I mean, so, you know, all these rules about, oh, if there's a sum or a difference or this, then do this, and if there's that, then do that, not really. You don't, I mean, at best, you don't need rules like that, and at worst, rules like that are going to make you take like 4 times as long to solve the problem, because you'll think you have to consider all these things that you don't really have to consider. So it's whichever one you're comfortable with. Now, what about when you study or review? When you study, does anybody know what we're going to say about this? Yep, CC is pretty much on task with this. You should try both. As many as you can. Because again, remember, that's the point. That's the point. That's really the only point. The point is just learning as many methods as possible without a preference. Remember, that's what we said in the other page was the whole point of studying quant. So, but yeah, because that way you can just pick and choose from the methods that come to mind. All right, nicely done. Go ahead and try this one right here. Okay. Answer buttons, there they are. Please use the answer buttons when you solve the problem. And here is a timer. All right, people, let's pick answers to this, please. If you have to guess, guess. But it's been about 2 minutes and 40 seconds already, which is kind of a long time for this problem. So if you are Katrina or Prob, you got to pick something. Okay, Katrina, no. Prob, no. Answers? Got to pick an answer here. You can't sit there and stare at it. Okay. Remember, if you're not answering the problem and if you are actually here, then you're not preparing for this actual test. So we have a pretty strong consensus here in favor of D. But what's a way that you can solve this without traditional methods? Anybody? Text box. What is meaning? Yeah, base 3rd grade method basically. Pick a number for n. I don't see an n in this problem. But yeah, you can just make a list. One way to do it. Color of the board, maybe you can explain what you mean by n, because nothing in this problem is actually called n. But one way to do it is the so-called grade school method, which, you know, back before you had any idea what algebra was or anything like that, you could just make a list. So if somebody walked 5 miles per hour, you could go 5, 10, 15, 20 every hour. So just list how many rotations each second. So gear P goes 10 revolutions per 60 seconds. So that's 1/6 revolution per second. And then gear Q goes 40 revolutions in 60 seconds. So that's 4/6, which is 2/3 of a revolution in every second. So you can just, because you don't have to go more than 15 seconds here. In fact, you don't have to go more than 12 seconds. So, it's because if you get to 12 seconds and it doesn't have what you want, then it's easy. So the most you have to go is going to be 12 seconds. This is not something that's going to take you a very long time. So seconds, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So illuminate. This program's weird. It waits a second after you press enter to actually skip the line, so you wind up with that sometimes. So gear P is 1/6 of a rev every second, so that is 2/6. 3/6, 4/6, 5/6, 1. 1 and 1/6, 1 and 2/6, 1 and 3/6, 1 and 5/6, 2. These are all off by 1. There. So, yeah. And then this. And then gear Q revolutions, you could put that as 4/6, so that's easier to look at. 1 and 2/6 is 1 1/3, and then 2. That's off again. So let's move those down. Okay. 2 and 4/6. 3 and 2/6, and 4. 4 and 4/6. 5 and 2/6, and 6. 6 and 4/6. 7 and 2/6. And 8. So 6 more revolutions is what we want. So that looks like the 12 seconds. 8 revs versus 2 revs. And so you're done. What about this? Well, somebody wrote this. This is another way that you could do the problem, and so we could call this another flexible method of solution. But depending on who you are, it might not save you time to do that. Because these are very systematic lists that are very easy to make. Like, I mean, it's honestly, Satish, it's probably faster to just go 1 6 2 6 3 6 4 6 5 6 1 than it is to keep looking back at these choices and keep having to multiply by choices that are essentially random. Like, I know that I personally would make this whole column a lot faster than I would just do these 5 numbers times 1 6. But you might be the opposite, and remember that at the end of the day, that's not the point anyway. The point is that we should be able to do it this way, and that we should also be able to do it that way. So that, and I mean, I think we're in agreement there. So, sorry about the noise in the background if you hear that. So, same thing with this. You might, you might just plug in the choices instead, but as long as you can do both. So it looks like a bunch of people are typing. You can also back solve, which is what these gentlemen are saying here, so let's go ahead and put that. You can also back solve. In other words, just plug in the choices. Like start with choice C in the middle. Like or D or B, but don't start with one of the extremes. Because I mean, if a middle choice is eliminated, you're getting rid of more possibilities. So remember that gear P is 1/6 revolution per second, and gear Q is 2/3. So answer choice, gear P revolutions and gear Q revolutions. So if the answer choice is C, then gear P goes 10/6, that's 1 2/3. And gear Q goes 20/3, which is 6 2/3. So the difference is only 5 revolutions. We want 6, so that means that not enough time has elapsed, because there would be a bigger difference if more time had elapsed. So that means that C is gone, but so are A and B. So it's between D and E at this point. Just pick one at random. So D, gear P revolution, goes 12/6, which is 2 revolutions. Typo. And then gear Q goes 24/3, which is 8 revolutions. So difference is 6 revolutions. This is what we want. So you can do that. This is not really true. Eliminate B and C right away because they're not multiples of 3 and 6. Let me put this in a red box here, and let me write next to it, no, period. That'll get you in trouble, because if you imagine that I had the question asking about 5 revolutions instead of 6. So if that's the question, then the answer is actually C. Even though these are fractional, the difference between them is exactly 5 revolutions. So you cannot assume that these are going to work out to be integers. And in this problem they do, but in a lot of problems they won't. So not here. If you have a ratio problem of like boys and girls or things that have to be whole numbers, then yes. But not here. Okay, you can also use more traditional ways, but the time here is about wrapping up, and I'm on kind of a tight schedule today, so we're going to have to close the session here. If you have any last-minute, quick admin-type questions, feel free to type those in. Thank you for coming today, and this should be posted on the internet in, our usual time frame, maybe by Monday or Tuesday or something. So thanks for attending, and the recording will be up in the usual amount of time. Good night, and good luck. And I'm going to go ahead and kill the recording.